Okay, Math 9, let's get after it here. We got a short video on dealing with negative bases because as we saw in the notes, positive bases are relatively simple to deal with, but when things get negative, things get tricky. So remember, the negatives matter with respect to repeated multiplication and with respect to what we call our forever positive and forever negative, which you're going to hear me talk about. So repeated multiplication means how can I write these as repeated multiplication? It might seem like a weird idea, but if you understand what it looks like as repeated multiplication, the odds of you making mistakes with positive or negatives are going to decrease substantially. So look at 2 to the power of 4. It means 2 times 2 times 2 times 2. It's 2 4 times. If you look at -2 in brackets to the power of 4, it means everything in those brackets times itself 4 times. And if you look at now, here's where things get interesting. No brackets. If you have no brackets, this negative at the front is just a -1 times 2 to the power of 4, which means you have -1 and then 2 times 2 times 2 times 2. The negative is not included with the exponent. Let me say that again. If there are no brackets, the negative is not included with the exponent. And then on this last one on the bottom, you can see you have a -1, but then you have -2 times -2 times -2 times -2. And if you look at these different things, you can tell whether or not things are going to be positive or negative. If you look at this top one, right here, everything's positive. So there's no way in hell this answer would ever be anything but positive. So we would call this forever positive. Now, if you look at the next one below, sure, we got a bunch of negatives here. But since we have an even number of them, since we have 4 of them, a negative times a negative is a positive. So all the negatives are actually going to cancel out. So this answer will also be positive. If you look at this one, it doesn't matter how many times you multiply that 2 together, you're always multiplying by a -1 at the end, which means you're always going to be negative. I'm going to talk about this more on the next slide, but I wanted to connect this here. And then we will look at this one a little bit closer in a minute. So this is exactly what I'm talking about with forever positive, forever negative, and how we can write this the synonymous version without the brackets. So here we have -2 times -2 times -2 times -2, which means, like I mentioned earlier, that's positive, that's positive. It's a positive times a positive at that point, so everything's positive. So we say this is forever positive, which means that -2 to the power of 4, if you have your negative in brackets and you have an even exponent, you can rewrite it as its positive counterpart, just 2 to the power of 4, because both those statements will be forever positive. Now, if you have a negative sign that is not encapsulated by those brackets, it means you have -1, and then in this case, 2 times 2 times 2. And down here, you have -1, 2 times 2 times 2 times 2. But in this scenario, it doesn't matter if you have an even or odd number for your exponent, because the -1 is still going to exist at the beginning of the multiplication. So in both of these cases, we have forever negative, and they just are written the way they're written. You can either write it as -2 to the 3, or you can write it as -1 times 2 to the 3. This version is helpful, and you'll see that in the next video when we talk about multiplying and dividing a common base. This would just be -2 to the 4, or we could say -1 times 2 to the 4. But the no brackets make a difference. It is forever negative. And then in this case, you'll see it's the same as the top one, except odd exponent. So that means we have -2 times -2 times -2. And in this case, you'd have a negative times a negative, which would give you a positive. But then you'd be multiplying by a negative, which is going to give you a negative result. So this is also forever negative. So we can write it as its negative counterpart, either like that or just like that. But writing it in this form will help us in the next video. So very, very important aspect of how to deal with negative symbols. The other thing we looked at in section 2.1 is determining the exponent. Now, when you get to grade 11 and 12, you'll start looking at things called logarithms. And logarithms are the mathematical inverse of an exponential, and they help us determine an exponent. but well above our pay grade at this point. All we're going to do is consider the fact that if 81 is equal to 3 to the power of something, it means I'm just going to have to divide 81 and see how many factors of 3 I get. Now, you may divide 81 by 3 and get 3 goes into 8, twice 2 remainder, 27, and then you get 9 times 3, and then you get 3 times 3. And would you look at that? Ends of my branches, 1, 2, 3, 4. So it must mean then that 81 is equal to 3 to the power of 4. Now you could have broken down 81 in any way, any of its multiple breakdowns. I know 81 is 9 times 9. That always jumps into my head. And then that still breaks down to 3 times 3 times 3 times 3. So in the end, we still have 4 3s. So dividing the given number here, 81, by the given base until you're totally done, and you'll only have the bases remaining. So if you look at 3,125, well, looks like I should be dividing it by 5 because it's to the power of question mark. And there's a slight typo there. It just should, the question mark should have appeared up higher. But 5 question mark. So 5 how many times? Well, divide by 5. 5 goes into 31 6 times with 1 remainder. 5 goes into 12 twice with 2 remainder. 5 goes into 25 5 times. If you're not sure what I just did there, watch my video on short division. It's similar to long division, but in my opinion, way better. So 625 divided by 5. 5 goes into 6 once with 1 remainder. 5 goes into 12 twice with 2 remainder. 5 goes into 25 5 times. Divide by 5 again. 5 goes into 12 twice with 2 remainder, and we get 25. And then 5 times 5. So what do we get? 1, 2, 3, 4, 5 fives. So that means that 5 to the power of 5 is equal to 3,125. So we're getting there through factoring. So again, imagine that comes back to factors. So there's a short on section 2.1. There's a full lesson here as well, but this was just a quick and easy one for a little brush up. All right, great work. Keep it up.